Welcome to another part of the ISM course in Statistics 1. This time with a unit on measures of central tendency, in particular for unclassified data. In a later session we will also talk about classified data. Here we just start with the simple unclassified versions. We do this with a simple example. Imagine we have a number of monkeys. Each of the monkey owns a number of lollipops. So the first monkey has 5, the second has 5, the third has 5, and so forth until the last one who has 160 lollipops. So a very rich monkey. What we do, we arrange this set of monkeys in an ascending fashion first. So the ones with the least lollipops are on the left, the ones with the most lollipops are on the right. And if we have this, we can very easily see or determine our measures of central tendency. The first one we have, that's a so-called mode. The mode is determined or defined as the most frequent value. If we take a look here, we have 3 monkeys with 5 lollipops, 2 monkeys with 15, and all the others have only 1. So the most frequent value here is the 5. This means that our mode, that's the XM, is 5. It's not necessarily this specific monkey the arrow points to, but the value. That's what we are interested in, and the value here for the mode is 5. That's a little bit different for the median. The median is not the most frequent. The median is the one in the middle. Now we already see where there's the big difference between modes and medians. For the mode, we only need to know the numbers. We only need to count. So the mode can be determined if we have nominal data. With nominal data, we can count, so we can determine the mode for nominal data. For the median, in the middle, so we need to have this arranged in ascending or descending fashion. So the median requires at least ordinal data. And well, the median is defined as the specific value where 50% of the observations are smaller than this value and 50% are larger. Practically speaking, what we are always doing, we take a look how many observations we have. So here we can take a look, we see we have 9 different monkeys. So this is an odd number of monkeys. In this case, we just find the observation in the middle. So in this case, we have this specific monkey here in the middle. There are 4 monkeys who have less lollipops, or the same number, and there are 4 monkeys who have more or the same number. So this monkey gives us the median. So the median is 15 lollipops. This always works if I have an odd number of observations. I pick the one value exactly in the middle, where of the values, if I skip this one in the middle, half of all the values are to the left, half of the values to the right, or 50% are smaller, 50% are larger. So far so good, but what would happen if I would have like 10 monkeys or 8 monkeys? In this case, that's the second formula here, I would have taken the average of the 2 values in the middle. So if this specific monkey here in the middle wouldn't exist, and I would only have the one to the left with the 10 and the one to the right with the 15, 8 monkeys in total, I would have to take the average of the 10 and the 15. So I would end up with a median of 12.5. So we see here we need to think a bit more, and we have to differentiate how many observations do we have. Is this an even number of observations or an odd number of observations? And then finally, well, as I said, this works for ordinal data. Then we have something which works for metric or at least for interval scale data, and that's the mean. The mean results if I take all values, sum all the values up, and then divide it by the number of observations. So here I would sum up all the values divided by 9. This is actually the formula. The big sigma just means sum up all the values and then 1 divided by n and divided by the number of observations. So if we do this here, we get as a result 30. So meaning our median is 30. It's just by chance that here we actually have a monkey who has 30 lollipops. Usually, the mean is not necessarily one of the original values. The mode always has to be one of the original values. The median can be one of the original values, or is the mean of 2 of the original values. And the mean could be any which value somewhere in between the observed values. Usually it's not one of the observed values. So with this in mind, we can also see here mode, median and mean not necessarily have to be the same number. There could be quite severe differences, as here with a mode of 5, a median of 15 and a mean of 30 lollipops. And this large differences, those usually occur if I have like 1 or 2 observations with very large or very small values. So here, this one monkey with 160 lollipops screws up our total data set. He has way more lollipops than all the other monkeys. So he actually influences, in particular, the mean very strongly. And that's one of the reasons why it's good to not only consider the mean, because if you have some outliers, like this rich monkey here on the right, usually this will have a severe effect on your mean. So one very large value leads to an overly large mean. One very small value leads to an overly small mean. So the mean is also very susceptible to outliers. The median, on the other hand, is not. So it's always a good idea to consider, well, the median, or if you work with the mean also is one of the most common ones, to at least take a look at the mean as well, or beforehand, and this would be the better idea, to check whether there are some severe outliers present. With this in mind, we then already covered the most important aspects of measures of central tendency. We discussed the mode, the median and the mean, the differences, and how the values could differ and when we can calculate those characteristics or the statistics at all. Well, with this, I say that I hope you enjoyed this short session, and if you want to see more of this type, feel free to visit the rest of this playlist and the rest of this course. Until then, see you and goodbye.